Welcome back to the fifth segment of the systems documentation tutorial. In the last segment, we created the physical data flow diagram. In this segment, we will create the logical data flow diagram. Remember that a logical data flow diagram captures the activities that occur in the process, not who or what performs them. Therefore, it's a conceptual diagram, not a physical. The first step to creating the logical data flow diagram is to group the activities into sub-processes. We will do this according to three general guidelines. First, we want to group the activities that occur at the same time in the same place. Second, we will try to group activities that occur at the same time but in different places. And third, if activities are conceptually related, we will group them. It's important to note that these guidelines are not mutually exclusive. For example, things that happen at the same time, but different places, are often conceptually related. When we have grouped the activities, we will have identified how many bubbles will appear on our logical data flow diagram. At that point, we'll just need to create meaningful names for the groups. This is more of an art than a science. Therefore, it's important to identify and list your assumptions, and we'll try to do that as we go along. So let's try this. First, we'll need our entity activity table. Look at the first 6 activities and imagine them playing out. So the customer gives the order to the sales rep. The sales rep enters it in the laptop. The laptop adds the order to the daily's order file, prints 2 copies of the order, and gives the order copy number 1 to the customer and files customer order copy number 2. Do all these things occur in the same place? Yes, most likely. Do they all occur at the same time? Yes, the sales rep will most likely give the customer his or her copy of the order before they separate. So let's color these activities in the same color, and that way we'll indicate that they're part of the same group. Make them a nice purple. And then if we go down to activity 7, notice the hint at the beginning. It says at the end of the day. So this activity doesn't occur at the same time necessarily as the previous 6 activities. Does 8 occur as the same time as 7? Most likely. There's no reason for the laptop to wait around before sending them. What about 9 and 10? Once the headquarter computer receives it, it calculates the various totals and records the totals and orders in the customer order file. So again, most likely the headquarter computer doesn't wait when it receives it. It'll just begin munching on the data when it arrives. And so we can take these 4 and color them a different color to indicate that they're part of the same group. But then in activity 11, each morning, notice the hint, and notice that phrases such as each morning and at the end of the day almost always indicate a batch process, which translates into an independent subprocess. So 11 starts another subprocess, and look what the computer and order entry clerk do in that subprocess. Each morning, the headquarter computer displays the customer order file with the totals to the order entry clerk, and then the order entry clerk reviews the orders. It makes a comparison with what the sales rep's totals were, and then it notifies the headquarter computer that it's okay to proceed. The computer then proceeds to perform a series of program edits, which is, as we discussed before, entailed in activities 16 through 21, at which point it then prints 2 copies of the sales order and sends 1 to the customer and 1 to the warehouse. So if we apply our guidelines here, do they happen at the same time in the same place? Well, they're all happening at the headquarter computer, minus a little interaction with the order entry clerk. Now, if we make the assumption that the order entry clerk is sitting there at headquarters, then they happen at the same time and same place. But even if the order entry clerk is not geographically located with the computer at headquarters, they are all happening at the same time. And we could also make an argument that they're conceptually related because it involves processing the order. So we'll go ahead and label these, color these. Oh, we got to do it in separate parts. We'll color these green to indicate that they're all part of the same group. Now if we zoom out here and we look at this, we've got 3 groups now, so that means we're going to have 3 subprocesses or 3 bubbles on our logical data flow diagram. But we need to be able to label these bubbles. So this first group, if you look closely, entails activities that involve entering the order. And so when we go to label this bubble, we can call it enter order. If you'd like, we can create a comment here, enter order. Now this second group, it's a little trickier. It's not quite as clear, so we'll come back to it. The third group begins with displaying the customer order file to the order entry clerk and ends with printing the picking ticket and the order acknowledgement, which gets sent to 2 different locations. Everything in between are steps taken to process and record the cell. So let's just call it process and record the cell. Implied in that label is the distinction between an order in its unprocessed form and a cell which has been processed. So in our labeling we'll make the distinction between an order and a cell. Now let's go back to the second group. Now we know that the second group needs to be named such that it indicates something that happens between entering the order and processing and recording the order. Some possibilities include pre-process orders, verify orders, and batch orders. See how those are all verbs or action phrases? Remember, on a logical data flow diagram, we are not labeling the bubbles with nouns, but with verbs or action phrases. In my interpretation, there isn't enough verification occurring to merit labeling this group verify orders. And pre-process orders is too similar to processing cells. So I'm going to opt to call it batch orders, as these steps collect and store the batched orders for further processing. Now again, this is more of an art than a science. You're free to interpret it however, just make sure that your labels make sense and are descriptive of what actually occurs within that subprocess. Now let's move over and begin creating this logical data flow diagram. As with the physical data flow diagram, we are going to start with the context diagram. So we'll copy that over and then move to our logical data flow tab. Remember, we deleted the one bubble that was on the context diagram because we want to preserve all the outer structure, because the purpose of the context diagram is to create or illustrate the system boundaries. So now, as we've already indicated, we need 3 process bubbles. So we're going to go back to the context and borrow that bubble. Now at this point, we're going to put these side by side so that we can see them. So now we'll refer back to our entity activity table while we create this diagram. We scroll to the top here. We can see that the customer gives the order to the sales rep. So we need to make a connection here. Entering into our enter order process, we need to have the customer order. Now technically, we'll leave these other 2 data flows unconnected, which will quickly reconnect, because In step 5, the sales rep gives customer order copy 1 to the customer. That serves as the order acknowledgement. And since logical data flow diagrams are conceptual diagrams, we'll maintain the conceptual name of customer order acknowledgement. But then the laptop at the end of the day retrieves the day's orders. Now notice part of the difficulty in working and creating logical data flow diagrams is we have to translate from who's or what's doing it to what is going on. So after we've entered the order, well, the hint here is that we've entered a different color for our activities. We have to enter a different process. That means that somehow enter order has to transfer information to the batch order process. And how do we do that? Well, it retrieves the day's orders, but where does it retrieve it from? If you recall from creating the physical data flow diagram, we had a daily orders data store, which was the laptop's hard disk. So it retrieves it from its hard disk. So we're just going to click over to the physical data flow diagram, copy the daily orders data store, and paste it in here. So while we're entering the orders, we're going to be storing this information on the laptop's disk. And since we're interacting with a data store, remember we don't have to label that data flow. And so it retrieves it from the daily orders. So we'll indicate that. We'll copy this and show that the batch order subprocess retrieves it from the daily orders. Now one thing you may notice is the laptop is actually working here in the enter order process as well as here in the batch order process. Only the laptop has access to its hard disk, but in these two separate conceptual processes, the laptop performs activities pertinent to those processes. Now inside this batch order process, there's some sub-processes. It calculates various totals, records the totals and orders in the customer order file. So we need to show it interacting with the customer order file. So we'll go over here to the physical data flow diagram. We'll borrow the customer orders, which is a disk, and we'll paste it in here, get Visio to come back for us. And we're going to show that this batch orders is storing it in the customer orders file. Then we'll drag it down here, just because looking forward, looking ahead, we can see that we're going to have to retrieve it from the customer orders file. In activity 11, each morning, the headquarter computer displays the customer order file with totals to the order entry clerk. And in order to do that, we know that it needs to retrieve that information. So as an input to the process and record cell activity, we're going to show it drawing from the customer orders. Now notice both of these situations we had keywords indicating that we're dealing with batch. So in the first, we had at the end of the day, and there at the end of the day it would retrieve it from the daily orders data store and send it and use it to batch the order and send it onto the headquarter computer. Likewise, when it says each morning, at the beginning of each morning it draws information from the customer orders. But notice the connection between those time hints and the use of data stores. So daily orders corresponds to the end of the day. We have to have some place to store it until the end of the day. And customer orders corresponds to each morning. We have to have some place to store it until we can process it each morning. At which point it performs a whole lot of things, but what we're interested right now is being able to integrate the rest of our data stores. So remember, we're going to be using the same data stores, so let's borrow them from the physical data flow diagram. We'll paste them here. One thing we skipped over as well is there's a data store over here for papers, a paper file for customer orders. And we actually interact with that. If you look back here at activity 6, the sales rep files the customer order copy to. So we're just going to go ahead and fix that gap and indicate that the sales rep, when they enters the order, is filing it away here. Let's see if we can make it look a little nicer. So now let's read back in our entity activity table to figure out how to connect these data stores. So we skim down here, we validate customer name and address with the customer master file. That entails reading. So let's indicate that. Checks inventory availability and prices in the inventory master file. Again, that entails reading. Checks customer's credit limit in the customer master file against the order amount, outstanding sales orders, the sales orders master file, and the accounts receivable. So each of those is going to entail reading. Then records the customer order in the sales order master file. This is where we're going to put an arrow showing that we're recording it back to the sales order master. So if we go format shape, we need to find the one that doesn't have an arrow. That one does. And we'll click on that. And then it reduces inventory balances. So that means we're going to update the inventory master. So we need to do the same here. Create an arrow going back indicating that we're writing to it. And then prints 2 copies of the sales order. One it sends to the customer, and that would be this right here, this sales order acknowledgement. I'm going to send to the customer. And the other is the picking ticket. And so we're going to drag this warehouse and the picking ticket data flow over here and connect it up with process 3.0. So let's zoom out and see it all. We'll actually expand this over here. So that completes our logical data flow diagram. Now in conclusion, I just want to remind you that this is more of an art than a science, and based on the assumptions that we take, we may end up with little different groupings and little different interaction of the data flows, because as you change the groupings, some of your data flows might change as well, especially as they interact with the data stores. In fact, if it makes you feel better, before I recorded this, I checked my old solution, and based on different assumptions, I actually had 2 different groupings between my old solution and this current solution. So that's why it's important that we understand how to use these guidelines, and based on different scenarios and different contexts, we might interpret the guidelines differently based on the needs of, in the real world, our client who we're working for. So hope you enjoyed this session. Hope to see you back here in the next and last segment, where we are going to show you how to create system flowcharts.